Hi, we are Team Robots Gone Wild. We're here to present our ideas to help prevent wildfires. I'm Kavya. I'm Kashfi.
And I'm Chinmay. Thank you for giving us your time to meet.
Here's what we plan on covering today. The problem we are trying to solve, the research we have done to learn more about it, and what our proposed solution is to this problem. First, the problem we're trying to solve. Almost 300,000 acres of land were burned by wildfires in Idaho in 2020. While this is a lot better than some previous years, it's not a particularly pleasing statistic. While some wildfires have natural causes, its effects are downright dangerous to almost everyone. Smoke from wildfires is detrimental to public health as it can cause respiratory and eye illness. Being asthmatic, I can personally attest to these effects. It has caused influenza to hit harder and spikes in patients at hospitals. Wildfires are also harmful to the environment as they release many greenhouse gases. As well as public health and the environment, wildfires also vastly impact the economy. Past wildfire seasons have cost billions of dollars in damages. We trust you also know about numerous effective wildfire prevention strategies, including prescribed burns to remove fuels, removing of dead and diseased trees, and removal of invasive species such as cheatgrass that worsen wildfires. You've even found articles on animal grazing to remove fuels. There are a lot of good ways to prevent wildfires. Correct us if we're wrong, but it seems to us from our research that prevention strategies are not the problem. Where to apply them is what seems a lot more difficult. This is a wildfire risk map we found from an organization called Wildfire Risk to Communities. As you can see, there's a lot of high-risk land in Idaho, way too much to apply prevention measures to. We can't prescribe burns hundreds of square miles, can we? This website also provided how they calculate risk, and as we were going through it, we found that the data supporting their conclusions is quite limited and outdated. This is the problem that we want to solve through innovation and technology. We want to be able to know exactly where wildfires are most likely to occur and let the relevant authorities know exactly where prevention measures are needed to save many resources and billions of dollars from wildfires. Here is what we have learned. In order to learn more about our problem and plan our solution, we started out by researching. From our research, we learned about the two different types of wildfire causes, man-made and natural causes. According to the Bureau of Indian Affairs, most wildfires are from man-made causes. While researching, we came to know about cheatgrass, which when it reaches its life's end becomes very flammable. Cheatgrass can cause wildfires to spread at more than 4 miles per hour. Cheatgrass is an invasive species which can spread dangerously quickly and overtake native crops. We also learned from our research that dead and diseased trees, especially in the Sierra Nevada forests, were linked to increase the risk of wildfires. Cheatgrass and dead and diseased vegetation act as fuel to wildfires, which can impact the severity of a wildfire. We also learned from the Idaho Department of Lands that dead and diseased vegetation is more endemic to Idaho and moved our focus to that. Before we started to plan our solution, we looked at some of the possible solutions and current wildfire prevention methods. One of the most common methods is prescribed burns to get rid of any hazardous fuels for wildfires. One of the current methods is goat grazing to also remove any hazardous fuels for wildfires. There are also numerous solutions from organizations and universities. A group of engineers came up with a solution to find wildfire risk in California using Landsat data. Alto University came up with an AI model to reduce wildfire risk by 50 to 70%.
Solution. Our idea to solve the problem. Now, as Benjamin Franklin once said, an ounce of prevention is worth a pound of cure, and we certainly believe that. Now, any solution that would work has 5 major requirements. The first is limited data. The solution needs to be able to produce results using limited data and resources, being able to access only aerial imagery. The second is that the solution must be able to produce results quickly. Time is an important factor in preventing wildfires. The third is that the solution must be cheap, both in terms of data analysis and data collection. And fourth, the solution must be able to handle large amounts of terrain and difficult terrain as well. And fifth, the results the solution presents must be specific in location, so wildfire prevention strategies can be more effectively applied in the region. Now, our proposed solution will consist of an AI model able to match all the requirements. First, we get data collected from the Idaho Department of Lands. Next, we label the data with experts to reflect wildfire risk in these regions. And we finally train the model on the labeled data. We estimate that we will need a large amount of labeled data. Now, the specific amount of data depends on the signal to noise ratio, as well as the similarity between land areas. The solution assumes that the features required to detect wildfire risk are visible in satellite images and or drone footage at all. Now, when in actual use, the input for the model will be a selected region of land, and the software will get the appropriate satellite imagery for that region. For example, here the entirety of Idaho, and then push it to the model, which will return a risk map with regions of the high risk highlighted, with objects that has triggered it also being returned. However, it is possible to apply this approach to drone footage as well as opposed to satellite imagery. At times, satellite images may not have enough information for the model to make a sufficient conclusion. Please note that the coloring of most of these slides is completely arbitrary.
This is our overarching solution. However, we wanted to focus in on a specific part of this process, the ground truth collection. It seems to us from our research that there currently is not a reliable and accurate method for ground truth collection. The concept was that we would use quadcopter drones to survey 1% of Idaho. From research, we can easily find information like the maximum speed and altitude, flight time, maximum control distance, and ability to customize. We found these values and we did the math. The results are as shown. To cover 1% of Idaho, 836 square miles, at a height of 80 meters from the ground, we would need 836 flights. This would take 200 plus days if we assume a 4-hour flight time per day. These values would shrink if we had multiple drones in the air at a time. After making these calculations, we went to visit and learn from an expert in the field, Mr. Chris Haskins, the Director of Research and Development at the drone company Thrust UAV. Here, we learned about a couple different types of drones, especially the fixed-wing plane. We also learned about some kinds of sensors that we can add to our prototype, such as the forward-looking infrared or FLIR camera, which could help detect dead and deceased vegetation if they had some sort of thermal footprint. However, we would need to do additional research on this. After learning about our wide range of options, we decided to switch to using a fixed-wing plane. With the 2 hours flight time and max ground speed of 65 miles per hour, we have 4 times the flight time and can cover 10 times the area. Additionally, the DJI drone is a closed system, meaning we would not have been able to add any sensors or program a flight path. This would mean relying on nothing but an RGB camera for visuals and a pilot's skills and time for the flight. The fixed-wing plane is highly customizable and can autonomously complete its mission when a flight path is programmed. This will speed up the ground truth collection process significantly from what the quadcopter drone would have been able to accomplish. This is why we've decided to use the fixed-wing plane instead.
Thanks for listening.
Thank you so much for giving us your time to present. We appreciate all the feedback that Ms. Schredener has given us, and we hope that we can get some more feedback from you, Mr. Breithman. We hope after meeting with you, the most important thing was that we learned something new.
Well, excellent. I didn't hear what grade is the team in?
I'm in 9th grade, and so is he, and she's in 6th grade.
Okay, excellent. Well, I really like the topic. I think it's very relevant. My background is working with the Forest Service, so I was a firefighter for 35 years. And so I have firsthand knowledge of a lot of the things that you were presenting about, including prevention and trying to do some kind of planning on how do we address such a large landscape, just like you found out. Idaho is just one state in the West, and it's huge. And there's obviously lots of public land. So when you look at other states, Montana, Colorado, Wyoming in the West, you're looking at large amounts of land that have to be assessed. So yeah, so trying to come up with some kind of a strategy based upon sampling makes a lot of sense to me. And so I liked your strategy on trying to sample based upon some number of samples. some number of samples to be accurate. One thing that I might point out is that, if you wanted to try to reduce the number of samples that you would have to collect, you might look at the risk. So I know you looked at, trying to map the vegetation, and that was sort of your sample population. Is that correct?
Yes.
What if you were to try to stratify that by areas with people? So areas that were adjacent to towns and cities and homes that would be at risk from wildfire. And so if you were to come up with a way to, let's say you've in your slide here, you have a picture of Boise, which, shows a large area. If you were to try to sample, maybe more intensively adjacent to cities and towns where there's houses and people, that might give you an opportunity to intensify your sampling, as well as identify places to treat fuels where that might make more difference to people and their safety. Rather than try to collect a lot of samples, maybe in areas where there are no people and there are no houses at risk. Just something to think about.
Yeah, thank you. That's a really good idea.
And they call that area urban interface.
Mm-hmm.
There's a term for that.
Yeah.
Wildlife urban interface. We learned about that from the IDL.
Yeah, exactly. So that might be one way to minimize the cost of sampling, and also try to really target places that are at most risk for wildfire and risk to humans and property.
Do you want to talk about the economic impact, that there's a lot of loss of timber that the IDL told us
Yeah.
in the wildlands?
Lots of lost timber in that as well.
Yeah.
In North Idaho, there's a lot of timber production
Timber industry. Yeah.
that comes to nothing.
Yeah, I think they're
Once it's
pretty
burned.
ideal that they are trying to prevent wildfires, especially in the timber areas, because those are a big part of the economy that they sell timber.
Absolutely, yeah. And Idaho has a big timber economy. A lot of towns are based upon sawmills, and a lot of people's jobs revolve around those sawmills. And so trying to, again, look at ways to maybe stratify the landscape for mapping and risk assessment might also, another way besides the urban interface, might be commercial timberlands. Areas that have been set aside specifically for growing trees that will be harvested, for wood products. So that may be another area to, maybe kind of limit, since you're looking at such large landscapes, thousands and millions of acres, maybe stratifying to, focus in on things like timber production might be a way to kind of narrow down, the cost and the scope of this kind of sampling. It's good. Another thing is watersheds. So, one of the things that forests produce not only are trees, but also water. And when we have forests that burn very intensely, like a lot of our fires have become, our fires are a lot more hot and intense, and they don't just kind of burn lightly, they actually consume the entire tree, as well as consume the duff and the upper layers of the soil. What ends up happening is that that vegetation is no longer there to trap water, to store water, and that water comes off the mountain that's been burned very quickly, and it causes flooding downstream, as well as sedimentation and erosion that affect fish and water for human consumption. So that's another negative impact of wildfires, as well as watershed impacts, water quality impacts, and that sort of thing. And so another key area that people focus on as far as trying to assess wildfire risk and try to treat fuels to minimize wildfires are looking at areas that provide water for cities. A lot of cities get their water from watersheds that are vegetated. And so towns that are small typically have a watershed that produces water that they use for drinking.
Yeah, that's really important. We do want to protect those vital resources.
Correct. Yeah. So this is all very relevant and very good information. I know the Forest Service and the Bureau of Land Management, public agencies that manage wildlands spend, millions of dollars every year trying to figure out where to treat fuels, how to get the most, benefit from the money that we spend. And they use exactly the same approach that you're talking about here. And I even was involved with a project using NASA. And so NASA has a lot of high resolution satellite imagery that allows us to do kind of the same thing that you're looking at with drones, but a lot more efficiently because, it's remotely sensed. It doesn't really require somebody to physically be there directing a drone. So NASA is a partner in this as well. That's great. So how did you pick this topic as something that you were interested in? Have you been up in the mountains seeing places where fires have burnt intensively?
Well, last year there was a fire in the Boise foothills that got really close to our school.
Ah,
And it almost reached River Glen and TVMSC, so it was especially relevant to Idaho how it happened in the foothills near our school.
Yeah.
that's good. Yeah, that really brings it home, doesn't it? When you see all that smoke and fire close to where you live, and there's really not much people can do to stop it.
Yeah.
So the best thing you can do is plan and prevent, hopefully, the fire getting close enough to cause damage by treating fuels, just like you were saying.
Mm-hmm.
Yeah. Excellent. Well, I think this is a great presentation. I think it's a great topic.
Thank you.
Thank you so
Thank you.
much.
Yeah. So what are you going to do with this information now?
Well, we plan to compete in the cyber mission competition, and
Oh, okay.
if we make it far enough, we may be eligible to receive a grant of $5,000 from the folks at eCyber Mission, and that could really help us implement all of our plans.
And continue our project.
Well, that's excellent. Well, good luck. I think you guys have got a very good project here. And I think some of the things that we talked about might be something to look at a little bit further and see if you want to incorporate into your report.
Yeah, for sure.
Yeah. Well, excellent.
So much, Bryce. Gosh, I'm like taking notes. I'm like, ooh, I got to mention that when I start talking about earth science and this for our climate unit.
Right. Yeah, it's all very, very relevant and very timely and very important.
Mm-hmm. And great job. Your presentation just sounds better and better and better.
Thank you.
Thank you.
Yes, very good. Yeah, and I would just say, when you talk, just make sure and kind of focus on breathing and talking slowly so everybody can follow along. There's a lot of information. And so you don't want people to kind of get lost because they're having a hard time keeping up. So I would just say, just as you're presenting, just think about talking, at a conversational pace, and people can follow along very, very well.
Mm-hmm.
Great.
Okay.
If there's anything else I can do, be sure and let me know. I'm like I said, I'm very, very interested in this kind of information. So if I can answer any questions, or if you have any questions or looking for other sources of information, I'm happy to help out.